Okay, well, welcome back to another day of FNF Code. Yeah, I had a bit of I was a little bit worried setting up the stream today because I ran brew install wget this morning on my laptop and it decided to download the internet. Decided somehow that it would upgrade all my packages for me, even though I just wanted to install wget. And so Vim was broken, Node was broken, but luckily Vim was auto upgraded, so it kind of fixed itself after the upgrade finished, but Node didn't. So I just ran brew upgrade Node, and it seems to be okay. I'm now on Node 15. It's running, so fingers crossed that it's going to work out. Yeah, let's take a quick look at yesterday's question again. Yesterday's question. It was a pretty weird question. I wonder how people did, actually. Let me just check the stats. Yeah, see yesterday's question, like if you got the first, you can see that almost everyone, so this first number, the gold number, right, is the number of people who finished both parts of the challenge. And is it gray or purple? I feel like it's purple. It says silver, I guess. Number is how many people completed just the first part, but didn't finish the second part. And you can see most people who finished the first part managed to do the second part. Because I guess, yeah, so maybe it wasn't just me. That first part pretty much was the whole puzzle. It's kind of interesting to look at this. Like, you can see, like, this one, number 10. What was the second half of 10? Yeah. 10 was trying to find the number of, this was the one about finding number of possibilities. You had to figure out the principle behind how to work this out. So it was almost impossible to brute force. I did actually talk to a friend who said that he brute forced it, but it was like a smart kind of brute force. So he skipped. He said he ran it with a little bit of optimization to the brute force, skipping over possibilities that he could kind of tell were not possible. And it took him 2.5 hours, I think. He went to have dinner, came back, and he had the answer. Hey, so props to him. As long as you get the answer, doesn't really matter how you do it, right? Let's see, 13 was another tricky one. What was 13? Shuttle search. No, okay, no. Okay, I messed up my stories. So my friend who brute forced it actually brute forced this one. He had a bit of smarts on how to identify the next possibility that he had to search, and avoided a bunch of possibilities. Basically, I think he only tested this number, then this number, then this number, or maybe he managed to combine the first two together and figured out how to do that. Yeah, you can see that was another tricky one. And if it wasn't for Blue Ghost, one of my thank you for always being here watching my stream, I probably would have been stuck on that one too. He pointed out the theorem, the mathematical theorem behind that particular challenge. Let's see, we got 50 seconds to go before the next one. What was another hard one? Passport processing. Validation seems to have tripped people up. That's interesting. What else? Day 20. Oh, day 20. Day 20 was hard. Look at that. Almost 40% of the people didn't manage to complete it. I was one of the people who didn't complete the second half. Even the first half of that. Look at that. Even the first part. Only 13,000 people completed the first part compared to the other challenges. So it was a pretty tricky one. Okay, anyway, here we go. We've got 10 seconds left, 5 seconds left. Let's hope today we have a good challenge. That'll be fun. Here we go. It only takes a few hours of sailing on the ocean for boredom to sink in. Fortunately, I have a deck of space cards. Space cards? Wait a second, what? There are two different... Oh, that's last year's. Oh, okay. So I like to play a game of combat. Do I need last year's? I don't think I have last year's. That's gonna be kind of sucky if I have to implement last year's one first. I like to play a game of combat. There's even an opponent available, a small crab that climbs on my thing. Before the game starts, split the cards so that each player has their own deck. My puzzle input. Player 1, player 2. Cool. Then the game consists of a series of rounds. Both players draw their top card, and the player with a higher value card wins the round. The player keeps both cards, places them on the bottom of their own deck. So it's kind of like Snap, but like the bigger just wins. If this causes the player to have all the cards, they win. The game ends. Consider that. The arrangement goes like this, etc., etc. Once the game ends, you can calculate a player's score. The bottom card in the deck is worth the value of the card multiplied by 1. The second from bottom card is worth the card multiplied by 2, and so on with 10 cards. The top card is worth the value of the card multiplied by 10. In this example, it's that. Playing this small crab. What is so we just play the game. That's pretty straightforward. So I'm going to call this P1 and P2 just to keep it straightforward, and I'm going to use the sample input as my test because I don't trust my ability to do this correctly the first time round without a test. Okay, so that's the test input. So see, this seems like it's just a loop, right? While p1.length is greater than 0 and p2.length is greater than 0, we pop the first card. Oops. No, we don't pop, we unshift, right? To get okay, well, we can slice at 0, I guess. It's not slice is the word is the function I was looking for before, not splice. Ugh. Okay. And you know what? You can use destructure, right? A equals 1, 2, 3. B C dot 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 equals A. Maybe it's dot dot C. B and C. Yes, perfect. So we can do that. So we can go const. So these can't be consts. Yeah, well, they can be, but P1 top 1 dot 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 P1 maybe. Let deck 1 equals P1, let deck 2 equals P2, let top 1 top 2. Top 1 dot 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 deck 1 equals deck 1. Can I assign it to itself? B A dot dot A equals A. A is now that, and B is that. Cool, I can do that. So const, not const. I actually don't need anything because this is just an assignment. Those 2. Who wins the round? If top 1 greater than, oh, what happens if it's a draw? Maybe there are no like equal cards. Maybe these are all unique numbers. They kind of look unique at a glance, so I'm gonna assume that they're always unique. So you're always gonna have one that's bigger than the other. If top 1 is greater than top 2, then player 1 gets the card. Which card goes on first? So that the winner's card is above the other card. Okay. So deck 1 dot push the winner's card, right? So 9 goes on top. Yeah, get dot push top 1, top 2 in that order. Else, deck 2 dot push top 2, top 1. Console.log, deck 1, console.log, deck 2. And I got myself into an infinite loop because I didn't use the right variable. Cool, is that correct? So apparently player 2-1. Yes, player 2-1, 3-2, 10, 6, 8, 5, 9, 4, 7, 1. So if deck1.length is greater than 0, okay, so const win equals deck1.length greater than 0. If it is, it's deck 1, otherwise it's deck 2. We want to multiply it by, well, we'll just loop it. Let I equals 0, I less than win.length, I plus plus. We'll just loop it because it's easier. There's 10 cards in the deck, right? Yep, so sum plus equals 10 minus I times win I. Console.log sum. Oops, I missed a bracket. 306. Seems good. So we will now copy in our input. We run it, and we get, that seems very wrong. How can I have negative points? Ah, I put 10 minus I. Oops, it's not 10 minus I, it's win.length minus I. 328083. Quite happy with that answer. Yes, 600, that's pretty good. Part 2, so I lost to the small crab, so I guess I was player 2. Fortunately, crabs aren't good at recursion. To defeat honor, you challenge to a game of recursive combat. Still starts filling the cards in 2 decks. You often play the same starting deck as before, it's only fair. Then the game consists of a series of rounds with a few changes. Before either player deals a card, if there was a previous round in this game that had the exact same cards in the same order in the same player's decks, the game instantly ends in a win for player 1. If there was a previous round in this game that had the exact same cards in the same order in the same player's decks, then player 1 just wins. So the crab is player 1, right? So we win. This prevents infinite games of recursive combat, which everyone agrees is a bad thing. Okay, sure. We'll keep reading. Otherwise, this round's cards must be in a new configuration. The players begin the round by drawing the top card of the deck's normal. If both players have at least as many cards remaining in their deck as the value of the card they just drew, the winner of the round is determined by playing a new game of recursive combat. See below. Otherwise, at least one player must not have enough cards left in their deck to recurse. This is starting to get very complicated. I read it out loud and I don't understand the rules. If both players have at least as many cards remaining in the deck, at least as many cards remaining in the deck, so equal or more cards in my deck as the value of the card I just drew, the winner of the round is determined by a new game of recursive combat. As in regular combat, the winner of the round, even if they won the round by winning a sub-game, takes the 2 cards dealt at the beginning of the round and places them at the bottom of the deck. Again, so the winner's card's on top of the other card. Note that the winner's card might be the lower valued card of the 2 cards if they won the round due to winning a sub-game. If collecting cards by winning the round causes the player to have all the cards in the game, they win and the game ends. Here's a small game that will loop forever without the infinite game prevention rule. During a game of recursive combat, if both players have at least as many cards in their own deck as the number of cards they have dealt. The winner of the round is known for recursing the sub-game of recursive combat. For example, if player 1 draws the 3 and the player 2 draws the 7, this would occur if player 1 has at least 3 cards left and player 2 has at least 7 cards left, not counting 3 and 7 that were drawn. To play a sub-game of recursive combat, each player creates a new deck by making a copy of the next cards in the deck that is equal to the number of cards they drew to trigger the sub-game. During the sub-game, the game that triggered is on hold and completely unaffected. No cards are removed from players' decks to form the sub-game. For example, if player 1 drew the 3 card, the deck is in the sub-game would be copies of the next 3 cards in the deck. Here is a complete gameplay where game 1 is a primary game of recursive combat. Okay, I'm just going to read it because reading out loud means I can't actually understand what's going on. Ah, you can't sub-game in this? Okay. So here we can get a sub-game. Right, and then because you win the second game, you go back. Okay. So we're going to update this a little bit so we can make copies of our decks so we don't mess things up. So 1, we'll slice from 1 to, we'll slice from 2 to 4. Okay, so slice is indexes, right? I'm holding a pen. 0, 1, 2, 3, 4. Okay. So I want to, so that will give me 2 cards. So this is 2 plus 2 would give me the number of cards I want. Okay. And A is unaffected, right? Perfect. So function play round I guess play game, huh? Deck 1, deck 2. I think I can still let. Okay, so I want to make copies of the decks in here. So I'll call these 1 and 2 because I'm running out of variable names. Let deck 1 equals 1.slice 0, 1.length. So that gives me a copy of the array, I'm pretty sure. Actually, I should double check that that is actually the case. Oops, that was a random choice, but it worked, so all good. Cool, and I can go a.slice 0 a.length to just give me a copy of the entire array, right? B equals that, A equals that, B 0 equals 1, 2, 3, B is that, and A is still that. Cool, does exactly as I want it to do. So I can still let top 1, top 2 like before. I think I can still pretty much do exactly this. So that would play a normal game. And then I can do something like, do I need the score of the winning deck, or do I just need, what is the winning player's score? Yeah, so I still need the winning score. So const win equals the deck that won. Then we calculate the score. And we return win. Oh, well, we just return win out of here. We'll calculate the score outside. That. Just return that straight up. Cool. Const win equals play game P1, P2. Cool. So that seems good for now. Test1 equals, what was test1? Same dex as in the example, 9, 2, 6, 3, 1. So I guess I understood the puzzle now, but it's a little bit, I don't think I explained it on stream. So it's basically you play the game. But if you ever both deal a card, right, and you both have at least that many number of cards left in your deck. So if I play, if in the example, if one player drew a 4 and a 3, and they both had 5 cards in the deck, then they both have at least 4 cards and 3 cards in the deck. So now you copy the top 4 cards from the player who played the 4, and you copy the top 3 cards from the player who played the 3, and you start a new game of recursive combat. So I'm going to do this, actually. And then whoever wins the recursive game wins the 4 and the 3 round, right? So it could be 4. So 4 and 3, usually 4 would win. But if they have enough cards, then now you have to play a new game with the copied cards, and whoever wins that game wins the 4-3 round. So then either the 3 and the 4 goes on top of the player with the 3, or the 4 and the 3 go on the bottom of the deck of the player who played the 4. So luckily, with programming, recursive stuff is quite straightforward, as long as we don't have to go too many layers down the stack. And I'm just gonna cross my fingers and hope that doesn't happen. I should kind of like do something like this, right? Recurse equals 0 equals 1. Let's go with. So I can go log recurse. I can't do that in JavaScript, can I? I can do that though. When? I should put P1 or P2 in here, but it's all good. Cool. So we draw the cards, we have this. So now we have to do an extra check in here. If deck 1.length is greater than or equal to top 1, and deck 2.length is greater than or equal to top 2, then we recurse. Because there's also that extra rule that if you ever repeat an exact same position, then you have to, then player 1 just wins. But I'm going to pretend that doesn't happen because it seems like extra logic that I don't want to implement right now. Then we have to copy the top X cards from the deck. So deck 1 already has the cards removed. So we want to go. We need to know who won. We need to know whether player 1 won or player 2 won, which is kind of annoying. So I can go level that, win that, and then win. And then win is the actual cards. Because I need to know who actually won. So const, I don't care. I can't call it winner. So win player equals play game. New one equals deck 1 dot slice from 0 to the top one. New 2 is deck 2.slice to top 2. Play game, new 1, new 2, and then just to keep track, recurse plus 1. So we know the winner. So this is going to be an else. Yeah, I know don't have to stack it that many times, but I will leave it like that. If when player is 1, then deck.push that, else. Oops, I deleted it. My bad. Deck.push that. Deck2.push that. And we keep going. 291 is the answer I have here. So I mean, it seems okay. I'm pretty sure, I think I remember reading the answer is 291. Yeah. So just gonna check my stuff. Level 1, wait, no, hang on. So level 2 has, yeah, game 2 has winner 2. Game 2 is winner 2, yes. And then back to game 1. We have game 3, which is, game 2 has a level 3. I have a level 3 in here, which is interesting. But like I end up with the correct order, and I wonder if, like, oh, like it's correct. So I may as well just run it and see what happens, right? Just gonna chuck a thing in here so I can keep track of my logs, and we just do this with P1 and P2 instead. So my program's frozen. It's like in some sort of infinite loop. Let me just read through this again. Should I like print it out? I mean, should I really just print it out the way that they print it out? What was the rule for breaking out of infinite loops? So we get to a certain point, right? And we play a game 2. And there are 7 cards, right? And these are the 7 cards in that game. And the finishing order should be 5, 10, 2, 9, 8, 7, 1. Good. Right, and then we request 2 levels deep in the next game. That's what happens. So we play this and play a sub game again, yeah. And then in that sub game, we win with 9, 7, 5, 10, 8. Yeah, which then brings us back a game, back a level, and we win 9, 7, 5. 7, 5, 4, 1, 10, 8, 9, 3. Good. And then we get to the new game and we win that with... Oh, and then we have another sub-game. Whoops. And that sub-game we win at 9, 7, 5, 10, 8. Yep, and then we come back to the top game and we win at 7, 5, etc. Cool. So it looks like I need to do the infinite loop logic. Before each no. Before either player deals a card, if there was a previous round in this game that had exactly the same cards in the same order in the same player's decks, the game instantly ends in a win for player 1. But these cards go up to what, 50? Yeah, they go to 50. If they go to 50, theoretically I could do this like base 51 kind of thing and store the results as numbers to know if... It's just, I don't know how I'm going to store an array. Okay, so I'm gonna do this like this. I'm gonna do a little... I don't know if this is necessary. It's probably not. I could probably just... You know what I'll do? I'll just do this. Const... if there's a previous round in this game that had the exact same cards in the same order in the same player's decks, right? Okay, so everything has to be the same. So history. I'll call this history. I'll make it a set. What I'm gonna do is... before either player draws a card, so that's at this point. Check history, right? I said before either player deals a card, so this is dealing the cards. I want to check the thing. So this is what I'm going to do. I'm going to deck1.join with a comma, and then I also want deck2.join with a comma. So I'm going to say const hash. It's not actually a hash. I'm just going to call it a hash. I won't call it a hash. State equals 1. It doesn't really matter what it is. 1. And then it's going to be deck1 joined with that. 2. As long as it's something unique that can uniquely identify this current state. I think that will uniquely identify the current state. If history state, then player 1 immediately wins the round. If it doesn't equal null, then player 1 immediately wins the round. So I got to figure out what that is here. Then player 1 immediately wins, and we win with deck 1. Cool. Now do level recurse. Recurse winner 1, deck 1, and we'll be able to tell that that's the case. I'll just put an R here, just so I can tell if that happens. Then history state equals true. Oops. So that was interesting. Okay. We have a level 2 winner here with the test input. When player 1 just has an 8. that state has not occurred twice. Why does it say it did? Okay, we can step backwards through this. 183, 410, 9, 7, 5, 6, 2, 8, 1, 3, 4, 10, 9, 7, 5. There's a 6, 2 in there. What's the 6, 2 doing in there? I'm actually doing this wrong. So after the first round, we have 2, 6, 4, 8, 7, 4, yeah. 6, 1, yep. 1, 6, 3, 5, 9. Yeah, 3, 1, 9, 5, 6, 4, 7, 10, 8, 2. Yeah, 1, 9, 6, 4, 10, 8, 7, 2. Yeah, 9, 5, 5, 6, 6, 4, 4, 9. Okay, so after 4, 9, and did it have to be in the same round? If there was a previous round in this game that had the exact same cards in the same order. No, so that doesn't count. So it's okay. You don't have to take the round into account. So now we have 9852, 1017, yep. We go 852, 5281, 281, 81, 1, 7, 5, 10, 2, 9, 8. We win. We go back up and we have 9, 8, 5, 2, 10, 1, 7, 6, 4. Yeah, 8, 5, 2, 1, 7, 10, 9, 5, 2, 8, 1. All that stuff, yeah, 2, 8, 1. Yep, that's good. Okay, so 2, 8, 1. So we go into a sub game now. 8, 1, 3, 4, 10, 9, 7, 5. 1, 8, 3, 4, 10, 9, 7, 5. So we have a winner, and so we go. No. We play another sub game. Wait, 1, 8, 3, 4, 10. Yeah, we play a sub game. We have 8, 10, 9, 7, 5. Good. 10 wins. So we go back. Yeah, 8, 3, 10, 9, 7, 5, 4, 1. We go up 3, 9, 7, 5 to 8. Cool. We go up a game. 8, 1, 3, 4, 6, 2, 3 that wins. We have 1, 4. This is wrong then, right? One, 8, 3, 4, 10, 9, 7, 5, 6, 2. We come into this game. If there was a previous round in the same, did it say same game? If there was a previous round in this game, that's a bit of ambiguous wording. In this game, I think what that means is that this history is actually in here. I think, in this game. So it's a local history, and that gives us 291. Okay, cool. Okay, let's not print the history out because that's gonna take forever. Ah, but that means we can cheat, right? Because what it means, I'm gonna let that run, because what that means is global history. And in global history, oh, we have an answer, never mind. I was gonna optimize it and cache the winners based on the state of the cards, but we have an answer now. So we just put it through. 700th. Okay, not too bad. Not too bad. I'm actually quite happy with that. Yeah, so right where before it finished, I was going to, I think it would have been faster if I didn't have this console log here as well, because I was printing out a lot of stuff. But yeah, so we were a bit tripped up with the, I was a bit tripped up with the definition, with the problem definition today. Yeah, it was actually quite wordy and quite hard for me to wrap my brain around. I don't know if that's just because I'm a little tired or whatever it was. But yeah, that last little bit, this history, I had it out here, which meant it was a global history. But the wording of it, I reckon it's a little ambiguous. It says, I mean, I guess like game, sub-game, a sub-game is still a game based on the way this is defined. So when it says if there was a previous round in this game, what that means is it means if there was a previous round in this sub-game, yeah, it said if there's a previous round in this sub-game, not in this game. And so that's why this history variable had to be inside here, because every game had its own history, had its own like local history. And so right before I got the answer, what I was going to do was actually, since we do know that games do repeat outside of an internal like a sub game, you could still end up with the same cards on both sides. You know what? Let's just implement it. What I wanted to do was just to cache the winner of the sub game. Maybe I couldn't have done that. I'm not sure. Maybe not with this while loop. Yeah. Yeah, nah, I don't think I can implement it right now. Oh, can I? I guess I could, right? What I could do is this. I could put it here. Const global state. Yeah, okay. So it's not really global state, but I'll call it global history equals this. Hey, Palgram, yeah, I see your message. Yeah, I got just after 600th, I think. But congrats. Hey, programming challenges are different for everyone. What works for some people works for others. So really cool that you got 3,000. And honestly, as long as you get it, I think it's worth celebrating. So good job. Yeah, these things aren't easy, and so well done. So it's not really global state, but I'm just going to call it global state here. So just going to cache what that is at this point. And then at the end here, what we can do is once we've determined our winners, we can go global history global state equals winner, like that. Yeah, I'm happy with that. Global state is that. So then here I can say if global history global state exists, then return global history global state console log repeated state. And now print it out. And this should significantly speed up you can see it here, for example, now that I've just paused it. That looks like it doesn't significantly speed it up that much. Oh, you know what? No, I know why. Because I missed another exit condition. I have another return over here. Global history, global state equals deck1, 1. Now we should be real quick. No, still going? All right. I guess not. We should be finding repeated states. Yeah, so here we go. We got some repeated states, and it just goes straight to the winner. But it looks like it didn't actually speed it up that much. If I print less, I wonder if I'll just print the level. Just so we can have a gauge of what's happening. No, it looks like it still actually goes on for quite a while. So it looks like keeping track of your global state, caching results of specific combinations of decks, and just returning straight out doesn't actually speed it up by that much, it looks like. Still has to play out the whole game. It was probably a little bit faster. But yeah, so that was this question for today. Hey, so to Pal, if you're going to attempt part 2, really good luck, best of luck to you. Yeah, hope you manage to come up with something that works. Do exploit the fact that your programming language can deal with recursion. It looks like it doesn't really repeat that many times down, so you probably won't run into any stack troubles. Implement it as it says, and yeah, best of luck to you with that. But that's it for me for today. It was a really cool challenge. I got 700 and 700, 600 and 700 today, which I'm pretty stoked about. Cool, so I will see you again tomorrow. We only have, this is 20 seconds, so we only have 3 more challenges left. So looking forward to some really good challenges. Cool, so I'll see you tomorrow. Enjoy the rest of your day. So I will see you again tomorrow. We only have, this is 20 seconds, so we only have 3 more challenges left. So looking forward to some really good challenges. Cool, so I'll see you tomorrow. Enjoy the rest of your day.